All right, guys. So, any questions? So we'll now do some of the fun slides. Okay. So let's look at electric eels. Now here's the idea. So the question is the following. So let's say here's an electric eel, and here's a fish. And this is all underwater, of course. And what this electric eel is capable of doing is it'll pass an electric current through the seawater, and this current is it'll pass a current of roughly about an amp, and this will kill the fish. But this current passes through the eel as well, and the eel does not die. So the question is, how is this possible? The same current passing through this fish killed it and didn't kill the eel. Okay. So what is going on? So as you guys know, that eels are expert physicists, and here's what's going on. So what the eel does is the following. It has a row of batteries. These are just specialized cells called electroplaques, and each electroplaque has a voltage of 0.15 volts, or a tenth of the batteries that you normally use. Okay. 150 millivolts, and each battery has an internal resistance of 0.25 ohms. Okay, so these batteries, they have 140 rows of them, of the electroplaques, and each row has 5,000 electroplaques. So each row has 5,000 of these. So if you add up the voltage, 5,000 times 1.15 is 750 volts. So that's a 750 volt battery. And there's 140 rows of them. Okay. So that's an electric eel. Yeah. So all these batteries, 750 volts connected in parallel, they will drive a current, and they can drive a current of 0.93 amps. Okay. So there's a 0.93 amp coming out of the eel, killing the fish, and then coming out. And now when it comes back to the tail of the eel, this 1 amp current gets split into 140 different currents. So now through each arm of this circuit in the eel, only 1/140th of a current amp is flowing. And that's how come the eel survives. It distributes this current into 140 branches, while the poor fish is not able to do that, and it goes through, the large current goes through one pathway in the fish, and it kills it. Okay. So that's what the eel does. Okay. So the current in each of the electroplaques itself is 1/40th of that, which is 0.006. Okay, so it's about 7 milliamps, and 7 milliamps through each branch the eel is able to handle. So pretty smart. All right, you guys might have seen these 3-way light bulbs. They have 2 filaments in them, and the way they work is you close one switch, and if you close S2, it'll act like a 100-watt bulb. If you close only S1, it'll be a 75-watt bulb, and if you close both switches, it'll be a 175-watt bulb. Okay, so a lot of high current devices have 3 prongs in them, and what it is so in case, so this thing only had 2 prongs, this device, in case the wire, there was damage to the wire and this wire touched the housing, then that current would flow through you. Okay. So if any damage occurred during use, that current will flow through you, and that's not a good thing. So what they do is the housing is grounded, and that's what the 3rd wire is about. And now, since this wire has lower resistance, the current will take the path of least resistance. So if the device gets damaged during use and there is a short circuit, this current will go through the housing to ground. So that's the safety measure. Now in a house, all devices are connected in parallel. So here is the power line coming from the power company, and you see you have a series of parallel connections. And the reason it's designed like that is in case this goes bad, this will, in case one element goes bad, one device goes bad, the rest of the devices can be working. If, for instance, if you connected everything, so we'll just say this is the symbol for an AC circuit. If all devices were connected in series, if this device went bad, then none of the other devices could be used. Yeah, so everything is connected in parallel. Okay. And even houses are connected in parallel. If something happened to this house, there would be power to all the rest of the houses. So still be power to all the rest of the houses. Okay. So anyway, so devices are connected in parallel in your house. Okay. Heavy duty appliances will require 240 volts. So your utility provides 2 live wires at 120 volts. And the 2 lines are 180 degrees out of phase. So when one wire is bringing in 120, is at 120 volts, the other is at minus 120 volts. And the difference between the two is 240 volts. Here's a circuit breaker. So this is a fuse that does not burn, so to speak. Okay, so this is a safety device, which is what you all have circuit breakers in your garages. Okay, and generally they're made of bimetallic strips. So if too large a current flows through these strips will heat up, except that they're different metals. So let's say the way this is designed, this will lengthen more, its length will increase more, and it'll bend and it'll fall into the gap, and the electrical connection will be broken. Okay. All right. Now I have a few slides